This video presentation is brought to you by the Pro Mathematics Academy. Welcome to another video presentation brought to you by the Pro Mathematics Academy. In this video, we'll be looking at factorization part 2, right? And when we talk about factorization, we're talking about the process by which a mathematical expression may be written as a product of its factors, okay? And the important rule we want to remember here is that we have to recognize each expression by way of its form. So in part 1, we looked at the highest common factor and also the method of grouping, right? So in this video, we'll be looking at the quadratic form as well as the difference of two squares form. All right, so moving right along, we look at the quadratic form. So when we talk about the quadratic form, we're basically talking about any expression that is in the form ax squared plus bx plus c, right? A is the coefficient of x squared, b is the coefficient of x, and c is our constant term, right? So whenever we are asked to factorize an expression that is in this form, we want to proceed as follows. First, we multiply the numbers a and c, right? And then 2, we find all pairs of factors of the product AC. Then select the pair which can be added or subtracted to give the number B, and then we replace BX in the expression with the equivalent sum or difference found in step 3. And finally, we finish off by factorizing by method of grouping. So the method which we use to factorize a quadratic expression is an extension of what we would have already learned when we learned how to use the method of grouping. All right, and I know that sounds like a mouthful, so we will proceed by looking at an example. So here, I've selected the example x squared minus 10x plus 21. And if we look at this form, we can rewrite this as 1 times x squared minus 10x plus 21, right? So that we may see clearly that a is equal to 1, right? So now let's look at our process that we are to follow. So the first thing that we want to do whenever we're factorizing an expression that is a quadratic, we want to identify a and c. So here, a is equal to 1 and c is equal to 21, right? So if I multiply a and c, this implies that ac is equal to 21 multiplied by 1, which is equal to 21, right? And what are the factors of 21? Right? So we have 21 times 1, right? We also have negative 21 times negative 1. We also have 7 times 3. We also have negative 7 times negative 3, right? And I can't think of any more factors off the top of my head. So here we have to examine these pairs, right? So here we have 4 pairs, 1, 2, 3, and 4. And we want to see which of these pairs we can add or subtract to give us b. In this case, b is equal to negative 10. So when I add 21 plus 1, this is equal to 22. When I add negative 21 plus negative 1, it's equal to negative 22. And when I add 7 plus 3, it's equal to 10. But negative 7 plus negative 3 is equal to negative 10. So therefore, the numbers we're looking for are negative 7 and negative 3, right? So then we proceed to go to step 4. Step 4 says replace bx in the expression with equivalent sum or difference. So the equivalent sum in this case is actually negative 7 plus negative 3. So this means that we take our quadratic expression x squared minus 10x plus 21, and we rewrite that as x squared minus 7x, right, minus 3x. And where did I get the 7 and 3 from? Over here where we did our arithmetic, right? So here we are replacing negative 10 with negative 7 and negative 3. And now we rewrite our expression and we have something that looks like what we would perform the method of grouping on. So here I can look at the first 2 terms and ask myself what is common in the first 2 terms. And I see that x is common. So here I factor out x. I'm now left with x minus 7 minus what is common here in the second 2 terms is a negative 3. So this gives me x minus 7. And if I look at this expression, I realize that this now has in common x minus 7. So I can factor out x minus 7. And now this gives me x minus 3. So finally, we can say that the expression has been factorized and the answer is x minus 7 times x minus 3. All right, so I know that that example is pretty basic. So we'll move on to a second example, right? And this one is a bit more rigorous. So here, the method is the same, right? So we want to identify what is our A and what is our C. So here, A is equal to 12 and C is equal to 3. So this means that AC is equal to 36, because if I multiply 3 times 12, I end up with 36. So now I have to find those factors of 36 that can give me negative 20. So I start off with 36 times 1, which is equal to 36, of course, which we can further look at to see if when we add 36 plus 1, if it's equal to what we're looking for here, it's 37, and what we're looking for is 20. So therefore, that's not it. We can further factorize it as negative 36 times negative 1, which is not what we're looking for either, right? And we can say that it's 9 times 4, or negative 9 times negative 4, or 6 times 6, or 12 times 3, or we can use 18 times 2, or negative 18 times negative 2. In this case, we see that we're looking for negative 18 plus negative 2, which is equal to negative 20. So therefore, we could have tried all of these numbers, but none of these pairs will actually add up to give us, none of these pairs right here will add up to give you negative 20, only negative 18 and negative 2. Once we've identified this pair, we can now move on to replace bx in the expression with our pairs that we just found. So now we can rewrite 12x squared minus 20x plus 3 as 12x squared minus 18x minus 2x plus 3, which now looks like an expression which we can perform the method of grouping on, which should be we should ask ourselves what is common in the first two terms, right? So when I look at the first two terms, I realize that 6 is common. So I can factor out 6 here, which gives me 6x. And this is 2x minus 3. In the second two terms, we realize that nothing is really common. And whenever nothing is common, you say that 1 is common. So here I take out negative 1. This gives me 2x minus 3. And now when I look at this expression, I realize that 2x minus 3 is common. So I take out 2x minus 3. And this leaves me with 6x minus 1 as the other factor. So therefore, I have now factorized the expression, right? 12x squared minus 20x plus 3. And I realize the answer is 2x minus 3 multiplied by 6x minus 1. Moving right along, our next expression that we're going to be looking at is one that is very common on our exam, and that is called difference of two squares form, right? So we want to be on the lookout for the following forms, right? X squared minus y squared, and that's the first form, right? Or a squared x squared minus c squared y squared. Whenever we see any of these forms, we should immediately think about the difference of two squares. And remember, whenever you factorize an expression, you're simply writing it as a product, right? You're simply writing it as a product. So here, we want to remember that number one rule is to rewrite the expression as a product of the difference and the sum. And we'll see what I mean by that when I look at these coming examples. So here are, I think, 4 examples, right? Starting with example number 1, we have, this one is simply 5 squared minus y squared, right? And whenever we have the difference of two squares form, we want to rewrite the expression as 5 minus y multiplied by 5 plus y. And it is as simple as that. Once we can identify a in the expression, so if I should go back to form 1, we say that x squared minus y squared is actually equal to x plus y multiplied by x minus y. Okay, and for the second example, where we have a squared x squared minus c squared y squared, we say that this is ax plus cy multiplied by ax minus cy. So once you have identified the form, you can immediately write down the factorized version of it. Okay, so let's move on to example number 2, here we have 36x squared. I am going to rewrite that as 6 squared x squared minus 49p squared, which is the same as 7 squared p squared. So this is exactly equivalent to the second form. So we know that this is 6x minus 7p multiplied by 6x plus 7p, right? And that is the answer. This method is really easy, but the important thing is for us to recognize the forms, right? Moving right along to example number 3, we see here we have x plus y squared minus 100. I'm going to rewrite this as x plus y squared minus 10 squared. And once I can recognize the two squared terms, then I rewrite this as x plus y, right, plus 10 in one bracket times x plus y minus 10 in the other bracket. Okay, and to put simply, that is the answer. Then we move on to example number 4, right, which is 81 minus 4m plus n all squared. So here I break this down. This is 9 squared minus 2 squared times m plus n all squared. So now that I can recognize all of the square terms, I can now say that this is 9 plus 2 times m plus n in one bracket, right? Whatever this squared term is, right? We want to take that number and we want to subtract this number times this. So we're just removing the squares, okay? And then in the other bracket, we will have 9 minus 2 times m plus n in bracket. Okay, and that is our final answer. Another example is example number 5, which seems to come up a lot, and persons tend to forget that when we square 1, it is the same as 1. So this gives us v plus 1 times v minus 1. Okay? That is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.